Hello, good afternoon, good evening, good morning, wherever you may be. I'm so excited today to be with you to share this topic of automation in pursuit of safety. There's this story of a man whose classmate, who he grew up with, went to the big city. He was living in the village. And this friend came back after a few years and told him that there's a lot of money to be made in the big city. He rides motorbikes as a taxi. So he's a taxi motorbike. And this man now decided to also go to the big city and ride a motorbike to make some money to support his family. So for 2, 3 years, he was saving up money to buy a motorbike. Finally, his grandmother also added a little money and he was able to get himself a 50cc motorbike. So, with all pomp and pageantry, with the village seeing him off, he rode all the way to the big city to make money to support his family. And on his first outing, just like the Titanic, he was involved in an accident. He was rushed to the hospital. Fortunately, he made it alive. But then, a week later, he was back home in the village as a double amputee. And now his family, he's now dependent on his family, and his family has to cater to his needs. Accidents are something none of us want to be involved in. Accidents shorten lives, they reduce the quality of life, shatter dreams, reputational implications, financial repercussions. We have so many bad things that happen when we are involved in an accident. And you being part of this webinar tells me that you share our belief that safety or the prevention of accidents can be actively pursued. At Senzel Consults, we believe that accidents are not acts of God. And the best way to prevent accidents is to have or develop a positive safety culture. You know, we have only one life, and unlike a cat, which has 9 lives, we have only one. And after this one, there's nothing else for us to do but to go wherever we need to go. So whilst we are here, we need to keep ourselves safe. And that is the aim of Senzel Consults. I would also like you in the chat to comment, send examples of situations that you've been in or from your industry as well. Keep the discussion going, keep it lively. So we'll start. The lecture is in 3 parts. We're going to discuss why we need automation. Are we using automation because we are just lazy and we want to rest whilst the machines do the work for us? Is that the only reason why we need automation? That'll be one topic we'll be discussing, why the need for automation. And whenever we use automation, it induces risks that did not exist before. For example, if you light a candle because you don't have electricity in the night, the fact that you've lighted the candle introduces a new risk into the system that did not exist hitherto. So what kind of risks is automation coming with when we start using automation? And then what can we do to harness the full power of automation so that we live in harmony with it? Nothing has been untouched by automation. Automation is everywhere, in agriculture, in our personal lives, everywhere. The moment we are born, we are exposed to hazards and risk, which can result in accidents. So we need to understand now why haven't we been able to stop accidents in full? Because it is part of life. All our activities involve risks. Sometimes the accidents happen like this one. 5 died in accident on Accra Kumasi Highway. But we never We never have a commitment to systematically, intentionally, and earnestly investigate the causes of these accidents. Okay. Since man started moving around, we have been having accidents. We just say, oh, it's sorry. We send our condolences. We send our prayers. That is all we do normally. Unless the accident involves a large number of people, you have a lot of multinationals in there, or there's some important personality that is involved in the accident, then all of a sudden we have the means or we have the desire to investigate and find out what really caused this accident because people need answers. And aviation accidents really fit this bill. Most aviation accidents, when they happen, we need to investigate because it meets these requirements. Large numbers of people are involved. We have multinationals, some important personalities may be in there. We also have accidents that could happen in a nuclear, for nuclear accidents. We have chemical accidents. We have offshore accidents, oil offshore. All these are accidents that we investigate. And these principles that we find from these can then be applied to the lesser accidents that we really do not investigate. Maybe when we do that, we will be able to reduce the accidents. In Ghana, for example, for the first half of this year, road accidents have killed more people than coronavirus has killed people. So we really need to address accidents. Now, so going off on aviation, how has the investigation of accidents gone about? In the early days of aviation, that is somewhere in the beginning of 20th century, where attention was on the equipment. There were these 35 passengers who boarded the de Havilland Comet, the world's first commercial jetliner. And you can imagine the joy, the happiness they had to be on board that aircraft. But unfortunately, 15 minutes into the flight, it disintegrated and none of them survived. So an investigation was done on this, and it was found out that the windows of the airline were square. And these square windows caused cracks to form, which led to the explosion or disintegration of the aircraft mid-air. So our attention in the early days was on the equipment. So we were trying to manufacture a perfect system. But even as the technology progressed, we are still having accidents. So we needed to find a new culprit, find out what is causing accidents to still happen, even though the technology has been perfected, for lack of a better word. And we noticed that the human being is also a cause of accidents. And investigations of the Bhopal accident in India, the 3 Mile Island in the USA, Chernobyl in the former Soviet Union, Tenerife, all of these pointed to the human being being the major source of the accident or the major cause of the accident. But we couldn't just leave it as human error because that is a very lazy way to define the cause of an accident. So late 20th century, early 21st century, it was found that it's not only the human per se, but even the organization itself can lead to an accident. The Challenger shuttle in 1986 accident that happened when the Challenger blew up. A lot of the errors that happened were because of organizational factors. The time they needed to make, the time they had already scrapped one launch, and they needed to move, and there was organizational pressures to overlook some hazard that people had brought up. So all these, we found out that causes of accidents is not just one item. It is a series of things that happen. And at any point in time, if you're able to break the chain, we can prevent an accident. But this is another topic for another discussion. Now, according to the National Safety Council of the United States, okay, they did a survey and found that they accounted for 90% of workplace accidents. Now, if you have ever traveled on the airport, you know your baggage is limited. You have limited to 23 kilograms, I think so, if you are economy. And if you go there and you are overweight, what do? You need to take out the heaviest item from your bag. You start with the heaviest item. Normally, for some of us who travel from Africa to Europe, that would be the local produce, the plantains, cassava, etc. We take those because those are the heaviest items. We take them out and we are more than likely to make the weight. So if human beings cause 90% of the accidents, would it not be advisable to take out the human from the chain? If we take out the human from the chain, we can make a very big, huge dent in accidents. So that is why we are shifting towards automation, so that we can take away the human. Now, we mentioned this earlier, the Chernobyl disaster. This was a perfectly good working system. There was nothing wrong with it. We just needed to run tests. So the human operator was supposed to run a test. And because of the human being, this accident occurred. So what is very frightening about this Chernobyl disaster is that even anybody with similar training, experience, and information may have behaved in the same way. So you notice that it wasn't really because it was those particular people, but it was because of everything surrounding this event that led to the accident. And anybody could have been in those people's shoes. So it makes sense, of course, to try and introduce automation. So that nowadays most systems are push to test. You just push a button and then the system automatically tests itself. So I'm trying to remove the human from the equation. But we know in our socio-technical systems nowadays, it's made up of the hardware, the software, the environment, and liveware. This system was developed first by Dr. Edwin Edwards in 1972. He was an ergonomist and an aviation psychologist. Now, when we look at his system, that he is the socio-technical system, we see that the liveware is at the center of this. This is the shell model. And the shell is just an acronym for the hardware, software, environment, and liveware. If this liveware is at the center, then every socio-technical system is humanocentric. That means it revolves around the human. But if we go further, we see that this is not only humanocentric, but it's egocentric. What do I mean by it is egocentric? It means that it revolves around you as an individual, not you as a human being, but you as Kofi, you as Simon, you as Genevieve. The system revolves around your personality, around you, around your experience, around your education, around your feelings at a particular moment, etc. So this is what is causing the issues now. And all these are mapped to each other. So we have the liveware hardware, the liveware software, the liveware environment, and then liveware and other livewares. So when you have a deficiency, let's say between the liveware and the hardware, that becomes an LH deficiency. So, for example, you have your seats that are not comfortable. Okay, you've been typing for long periods of time. You start developing carpal tunnel syndrome. You develop back aches because of your seat. Okay, human beings will adapt till they get to their limit, and then they will keep on adapting some more till an accident occurs or an injury happens or an occupational injury occurs. So that is what happens when we have the liveware hardware. Then we have the liveware software. Okay, so these are the layout of procedures. So these kind of accidents, when they happen, are conspicuous in accident reports. We can see them in accident reports, but it's very difficult to observe beforehand. Liveware environment is twofold, where the environment is modified to suit the human, which is, let's say, pressurization tanks, submarines. We modify the environment to suit the human, or the human is, we put on clothes to adapt to the environment. So we have oxygen masks, we have helmets, etc. Okay. So these two liveware environment issues also exist. And because of our modern technology now, technology doesn't really need to sleep. So humans are working 24/7, and that interferes with our circadian rhythms, etc. And humans are more prone to accidents. And then we should even talk about the liveware. That is human to human. That is one of the weakest links in this socio-technical system. Imagine if you have a system with 5 people, you have a team with 5 people, then it means there are 5 egocentric universes trying to work together to achieve an aim. If this was not a problem, if we just say, okay, this person is very well trained, this person is very well trained, let's put them together, and then the system will work. That doesn't happen. Manchester United, unfortunately, has shown us that putting stars together does not really achieve results. I'm sorry if you're a Man U fan, but I needed to use your example to illustrate this point. Okay. So we have nowadays, our attention has been drawn towards crew resource training for the cockpit teams, drilling teams, etc., so that we can get the liveware to cooperate and work fully. So if we take out this liveware, which is the most plastic and the most amendable component of the system, it will be easier to work around the systems, because you don't have to consider environmental factors to sustain life if you take out the liveware. So that is why now there is a push for automation, and it is affecting every environment.